Welcome everyone to our 115th Learn Fast webinar series. This is the 41st of 2021. We've been having a good time with as a big of array of different types of videos that we can do, and we're always looking forward to having our co-host here with us today, Peter Krause. And one of I try to balance as best I can, super technical ones. This button does this. How does this function actually work? Those kind of things. And then, but it's also important to me to have that driver coach perspective, how to not just use the buttons, but how to read the data and translate that into, speed on the track. And then, of course, as we had just a couple of weeks ago, when we had an author on that came on and talked about a couple of his books about the Beast, Jade Gers, and also the Al Unser Jr. Book that he was just putting out. And by the way, I ordered mine and got it, and I've read about not as much as I'd like, but maybe about 25% of it, and a very, very enjoyable book, that the new Al Unser Jr. book that he spoke about. So if you have a chance, you might want to order that. It's a pretty special book, pretty special story. So, but having Peter here is one of these times when we're going to chat about, there'll be some technical things in there, but we're really going to be looking at squiggly lines and video and understanding how to turn that into the speed on the track, the hardest part of going faster. What is the hardest spot of understanding how to get from the squiggly lines and into action on the track with your hands and your feet. So we're going to do that, and I appreciate Peter, you being here again. It's looking forward to having a good time today.
Well, thank you, Roger. I'll tell you, it's always a pleasure to be here, and I really enjoy the support from the entire AIM team, from you, from James, from McKnight, from Robbie and Robinson Shea and Brick, and of course, it all comes down from Emiliano. So it's really, really helpful, and these are great tools. And that's the whole purpose of these webinars, is to help leverage the information that you collect. All these things are just recorders. They record information so that you can review it objectively and without judgment. Doesn't tell you you're great, doesn't tell you you're terrible, it just tells you what happened.
Yeah, it tells you what you are.
but I have to say, we've got a lot of really, really good technicians out there. I mean, I think of people like Jeff Wasilko, and I think of Matt as being great technicians. They really know how to navigate the software very well. This is really not one of those things that we're going to talk about today. We're going to talk about the hardest part of going faster, which is not necessarily one thing. That's the key. It's not really just zooming in and finding the silver bullet. It is looking at the relationship between several different measures to validate and make sure that you're doing what you think you did. And in the areas where you didn't do what you think you did, where you can do it better. And so much of my business, we'll go to the next slide and really just talk a little, just for, 90 seconds about my business. I was a professional coach for club level racing drivers, track day drivers, and HPDE before it was a thing. I had a shop for 25 years. I worked on Italian cars, primarily Alfa Romeo and Ferrari automobiles. I've raced Alfa Romeos for 30 years, Fiats for 30 years, Fiat Abarths. I love all things Italian, and really enjoyed it for a long time. But when I sold my business in July of 2007, could not ask for better timing. I went into the private coaching business. I needed something to differentiate my information and my advice from other people. And part of that was, how do we, how do we make this more objective? Instead of what I think you ought to do, let's look at what you're doing and pick one or two things for the very next session that you can implement and put into place. So for 24 years, I've been dabbling with data, first with Stack and Pi, then with the first GPS based system, which was the Race Technology DL1 in 2001. I spent a lot of time, sold thousands of TrackMates, which are wonderful. AIM actually has a wonderful ability within the software to Race Studio 2 analysis to import TrackMate files so that you can upgrade from basically an older, more obsolete system to something current and powerful, which is what AIM is. And I'm really brand agnostic. I love AIM, but I love a lot of other systems, and I don't really care what people use as long as they use something. And that was my goal, was to have this driver coaching business work on an objective level, and basically an intelligent conversation between two drivers trying to figure out what to do next. And that's what we're really going to talk about today.
It's kind of funny you mentioned the TrackMate thing, right? I was at the NASA Nationals in Daytona a few weeks ago, and I was asked a bunch of questions from a bunch of different people, and normal support kind of stuff. But I'll bet you, I think it was 3 different people came up to me still using the TrackMate import data process into Race Studio. They had an old TrackMate running in one of their buddies' cars, and they were still bringing that in and putting it up against all of their AIM hardware. So that you're right, that has been a function that has been worked out very well for everybody.
Really, really good note from Kyle Watkins saying that basically he's been able to do that in import into Race Studio 3, and everything works as it should. TrackMate hasn't been made in 7 years. TrackMate is in the past. AIM is in the future. I got to tell you, I am so excited about Race Studio 3 analysis. It is not funny how much I love Race Studio 3 analysis. I think that the idea of having the video within the data analysis window with the video auto synced with the strip charts and the scatter plots and the heat maps is awesome. And really, I appreciate everything that the AIM team has done to put that together. I think we're getting close to the release candidate, hopefully, and the last update has been just fabulous. But video and data are key to auditing your performance. What we're trying to do is wrap our heads around the idea of making ourselves comfortable being slightly uncomfortable. We have to push the edges. Too many drivers start by doing the same thing, coming back into the paddock and expecting a different result, a different lap time, a different plus minus, any of that sort of thing. And the problem is they get upset, they get frustrated because nothing has changed. And so what they often end up doing is throwing it against the wall, throwing the long bomb, the football into the entry of the corner, and it all comes to tears. But we'll talk more about that in a minute.
Comes to tears. The couple of last little things as Peter gets ready to take over and kind of run this thing. I'm going to give him the mouse, but we're going to talk about some different links and some different things. If you're watching live right now, the chat box, all those links are going in there. Peter may mention some, I may mention some. If you're watching this later on YouTube, if you go down to the description box below, it might say show more or a button like that. If you open that up, all of the links and all of the information we're going to talk about will be in there as well. So if you're watching this later and we talk about a link or a document or something, just go down in there and you'll find all the stuff that we're talking about, including a link to the presentation materials that we're viewing right now. So everybody will be able to download that and look at it as a PDF if they would like as well. So Peter, I'm going to go over here and try to give you control of this this mouse, and let's see, remote control.
Tried to desensitize my touchpad, but we'll see how it goes.
Exactly.
Yeah.
And I think, and let me take it back for just a quick second. I closed closed my chat box. I need to have that back open, and you should be able to click and go and run away.
Fantastic.
Okay.
So the final, the photograph here is I'm on the grid at Circuit of the Americas in Austin, Texas, in front of a whole bunch of Can-Am cars with my 150 horsepower Sports 2000. I love these old cars. My car is a 40-year-old English car called a Taiga. It was put together by Tim Shankin and Howden Ganley. I know that there are a lot of people on this webinar that drive a lot of different cars and don't even drive cars, drive UTVs, bikes, all kinds of other stuff. I know you like my car, David. I know you do. And the thing is that I just think it's a very classy car. It's a very 70s looking car. I love historic cars because of the depth and breadth and variety. I love old timer racing. I love vintage historic racing. and this is really, really fun. So we'll talk a little bit about this, and Kyle, I think you're really going to enjoy this presentation
I was just
because
going to mention that, if you're watching this later, you probably can't see the questions, but Kyle is asking, how do we get to become that guy that can feel more comfortable? Being uncomfortable is basically what Kyle's questions are, and that you're going to find that Peter's going to walk you through about 7 or 8 steps of exactly how to do that here today. So sit back and enjoy.
I will tell you that the short answer, Kyle, though, is to do it incrementally, to continually break down to the smallest individual skill execution every control input that is done in the car, both the amplitude, which is how much, and the speed, which is how fast you apply the pedal or apply the steering wheel. So really what we're doing is deconstructing. We are accumulating information. Let me go ahead. Do I have the, yes, I do. All right, I got the power. Yeah, Matt says deliberate practice. That's the sort of thing. But let's start with the easy. Instead of the hardest thing, let's start with the easy. We optimize the corner exit first. Get the turning done. So many drivers put the cart before the horse. They are going to sit there and they are going to go back to power before the car is pointed in the right direction. So they might actually get to the midpoint of the corner or just early in the corner, and they might go to power, and that's just going to cause the car to understeer, take weight off the front tires, and go right off the outside. We'll talk about that more later, but it is purely an investment. Corner entry and corner exit. The corner exit is the return. The corner entry is the investment. You've got to give it up to get it. You've got to get the car turned, and you got to get the turning done. The more powerful the car, the bigger and heavier and powerful that the car is, the more important is to get the turning moment over with so that the car is pointed in the right direction and you can pull the trigger on that gun, which is a commitment not only to throttle, but to wide open throttle and get the car out of the corner down the subsequent straight for sure. Roger, I mean, I think this is self-explanatory. We don't really need to talk about this. I want to give a big shout out to Jonathan Goring, who I asked for permission to use the next 3 diagrams in the next 3 slides, because I think Jonathan is one of the great up and coming lights of professional driving coaches. I have watched him from the time that he was on a tricycle at Lime Rock to winning MX5 Cup, and then he won the IMSA prototype championship, prototype lights championship, and then he won the national championship in SCCA at Daytona at the runoff. So he can walk the walk, and he has a wonderful way of explaining the information like a lot of other people do. Jonathan Colborn.
James Colborn. Yep.
James Colborn does a wonderful job too.
And Jonathan has been a co-host with here a couple of times, and we've put the links Absolutely. To his website and his driver wisdom page. Very impressive place to go visit. It's
really easy to get into the weeds. And what we really need to do is back up and look at what goes into success and emulate those things to get success. So this is part of what we're talking about. Something as simple as car placement at the apex. If a car is wide of the apex, you've got to continue the steering input for a longer period of time. Hence, you cannot complete the application to wide open throttle. So it all starts with very simple things: car placement at the apex, and then a continuous progressive application of the throttle to wide open throttle. I mean, this sounds simple, but I'm telling you right now, if it was simple, everybody would do it, and they don't. I have 15 terabytes of video and data over the last 15 years of people doing it wrong. And I would say that the people who do it well don't even think they do it well. They always think that it's possible to do better. So here what we have is on the top left-hand side, we just have a speed versus distance trace. I love this trace because we can tell more about what's happening than any other single thing. We see the acceleration up to Sebring, turn 7, which is the safety pin, the hairpin. And we see a nice uniform linear deceleration, which means we have a constant rate of slowing. Now, why is this important? A constant rate of slowing allows you to plan on how fast you're going to be when you get to the end of the braking zone. And that is going to be critical to nudging up corner speed entry incrementally, piece at a time. But what is happening here is we've got a steady rate of deceleration. We have very little time and distance covered at a very low speed, which doesn't hurt the average as much. And then we have constant, immediate acceleration and gaining of speed out of the corner. In the bottom, we have GPS longitudinal G, or probably perhaps the real G, the accelerometer red G. And then what happens is you can sit there and see the attack of the brake aggression, how quick this deceleration rate rises. We can see that the deceleration is front loaded. It happens early in the braking zone. We're going to come back to this. So I'm trying to drive into you by showing you good looking data, what we're looking for. What is the benchmark? What are we trying to do here? What do we want people to do? What do you want? What do you want to do when you're in the car? Well, I want to make it look like this. So I don't know what the spike is just before. Could be a bump. I know that this section of the track is pretty bumpy.
It's
I don't know why he would, if he lost traction or gained traction, he might get a little bit more longitudinal G positive, which is above this black horizontal line. But for now, what we're going to do is we're just going to smooth this out and just say, look, we've got lots of fast, quick attack and good brake aggression. We have a peak immediately or early in the brake zone. Then we see a nice trail off. And most importantly, even though this is a long corner meaning tighter than 90 degrees, we have no distance covered or very little distance covered between the release of the brake and the application of throttle. That is really, 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 really important. Now, this could be a little breathe or a shift, most likely coming off the corner, and then we accelerate more, and then there's another shift, and then we accelerate more. But this is a wonderful, simple graph that tells you exactly what the heck's going on, and this is really, 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 really good. So moving on to the next thing. Again, I'm sorry for those of you who have this drilled into your head. I listen to this all the time. Why do we have to go to another driver's meeting? We've only heard this information about 1 million times. Well, I'm going to give it to you again. The whole idea of all of this is the driver that utilizes more of the demonstrated capability of the car over a percentage of the lap is going to be the person who is quicker than other people. That is super, super, super important. So to maximize the total use of the tires is the goal. Now, going straight, you're not really taxing them. You're not really focused on that. Yes, coming in a low gear and a high horsepower car coming off the corner, we're going to watch that because that's a test. Yes, that can be an effort. Braking can be an effort because we can overpower the tires and the tires' tractive capability of staying in touch with the road. But the idea is to utilize as much of the demonstrated capacity as possible. And we have that here. So basically, when you're accelerating, and then you hit the brakes, and all of a sudden this is looking down at something hanging from the rear view mirror. This is the front of the car. This is the back of the car. This is the left of the car. This is right of the car. But the whole idea is we're accelerating, and then bang, we get to a maximum longitudinal reading, and then we blend the end of braking into maximum cornering. Lateral G directly replaces and integrates with the increase in lateral G integrates with the reduction of longitudinal G in the same proportion, walking around the very edge of the friction circle. This is why this has got to be on anybody's profile because this is the number one test. I mean, Guangming did a really good job of explaining this to some folks who are trying to coach themselves in iRacing. So this is really, really good. The GSum remains the same. The GSum is not simply a addition of one axis plus one plus the other axis. It is actually a mathematical formula. We know about that. We'll be plenty of other people that talk about a lot. So here we have, foot moves from the brake to the throttle, and then the forces go below the midpoint. And then when you're accelerating straight on, it goes forward. So this is a really, really good setup. The reference to the very top, Buddy Faye's lateral G benchmark for longitudinal capability. This was an observation that the trained engineer, Buddy Faye, who wrote basically the seminal book on data acquisition benchmarking in 1993, Data Power, said basically if you had street tires and your brake system was working properly, you should be able to slow you should be able to slow at a very high level, say 1G. If you were on street tires and you were trying to corner and you wanted to know if you were close to the limit, Buddy said, if you're on street tires, you should get about 90% maximum sustained lateral G from the capability, the demonstrated capability of maximum longitudinal G, which is the braking force. If you had R-comp tires, so Hoosier, R7s, Toyo, RRs, these other sticky tires, Yokohama Advans, not slicks, but DOT tires with sipes and treads and stuff. It should be 95% required by a lot of the racing classes. So 95% of the maximum braking facility should be available in left or right turns. Then if you're on slicks, without aero, without the introduction of additional aerodynamic force pushing the platform down to the ground, it should be close to 100%. So 95 to 100% is the goal. So the numbers should be similar. If the numbers are not similar, there's a problem. Roger, you talked to a very experienced high horsepower, big GT car driver and asked him that same question.
Yeah, just recently, a friend, a local friend of mine, Scotty B. White, was working with his new Viper. He has a couple of them now, and he was heading to Indy for the runoffs. And he contacted me, and we were chatting. And I went up to a shop, and we were looking. And he was thinking that he's a lot of experience, right? And he was thinking, "Gosh, I'm not sure I'm getting everything out of the car laterally, but I'm a little afraid to just step it up there, right?" Which Peter's going to talk a lot about here in the next few slides. And I went to Buddy Faye's point, which Peter has made many times in the past, of this percentages of what should be available laterally. And when we looked at his data and we sat down and we started to go through it and bring up session after session after session, darned if he wasn't right. And his gut feeling was that he was not quite getting there, but he wanted something to help him understand it. And I brought this process up, and he was able to swell out the lateral side of his friction circle by just knowing that's where he should work, right? So it ended up being a perfect tool for Scotty, and he had some good luck.
So I'm going to talk a little bit to Kent Carter. I'm not going to spend a lot of time on that, but Kent, just because you can achieve that longitudinal G doesn't necessarily mean you should. So in a B spec car or a very low powered car, it doesn't necessarily mean you should go to threshold braking, but you need to know it is there, because you need to be able to compress the braking zone, and you need your braking zone to be consistently the same length as long as the braking system is functioning at high efficiency. That's the number one thing. So the next step really is, we can measure all of this without sensors. What we're doing is measuring the end result. We're just measuring the end result. See, the Solo 2 is a great tool. I tell you, James Colborn's GPS switches are the daddy. I can throw a Solo 2 in a car and get a pretty good idea of how much of the demonstrated capability of the car the driver is using simply from these measures. But more importantly, what we're looking at is the relationship between these measures. Too often, drivers look at one measure and don't look at it from another perspective to gain a much more fuller picture. And here we have everything we need on one screen. We've got a portion of the friction circle, this being the vertical axis, 0. And then what we do is we have this, which is the longitudinal axis, which is right here, is 0. This could be scaled a little bit better. There's some discussion in the chat that's worthwhile looking at. Those people that do one axis well are a dime a dozen. So the people that brake well, go bang, pin the brakes, get the nose to kiss the pavement, are that's easy to do. If they release the brakes and coast and roll without really taxing the tires, there's this depression, this cutout, which is this blue dotted line, to maximum lateral acceleration, which is over here. Now this car is, you know, braking at 1G and got maximum of over 1.25. Now we need to know that the topography of this track is that this is downhill, so braking is sketchy anyway, and then the road levels out and there is some vertical component and the car squashes in and can sustain a little bit more of a vertical load. That helps the tire a bunch, really, really works well. And the whole goal here is to maximize the use of the tire. Trade longitudinal G for lateral G, and then validate the demonstrated capacity of the car with GSum. Really, really good. Super. Yeah, you could add a slope channel if you like, but all you got to do is walk the track and you can figure that out. It's not evident in the car. That's the key thing. For those people who never walk the track and just focus on driving it, you do need the slope. If you walk it, it's better too. And camber, there is a gain, camber gain, as you not only gain camber, but also lose it. And that's why nothing is static. It's all dynamic. It moves all the time.
Camber of the track, not camber of the front suspension. Yeah. Peter, right. You've kind of talked about the GSum a little bit and got everybody kind of excited about it. This next series of slides, Kyle was asking earlier, is all good. We can chat about this, but how to, how do I apply all these things or apply it to a person that I'm working with? Peter's about to go into a series of slides here where he's going to start to talk about the how-to, Kyle. So make sure that you, I'm not picking on you. It's just this is when your comment came up, I thought, oh, wait till you see where we're going here, because he's going to break this down into small little pieces that are actually easy to understand and to share with your drivers. So starting off here, we've zoomed in now. We've got just a couple of basic channels, and now you're going to start showing the wrong way to look at it and the right way and how to actually fix it.
Well, so, I mean, the biggest issue, the biggest issue is familiarity with the track, familiarity with the car. What no driver has is a familiarity with how the car will react when presented with a particular force at a particular point. I think that we are very fortunate because a lion's share of the data that we're about to look at is from a top level GT car racer, a GT class winner in IMSA, and in some one make series. The car that we're looking at is a big winged slick shod GT one make car, capable of low 120s, 122, high 122, low 123 at Road Atlanta. So this is really, really, really good data. Now, even this is showing how difficult it is. The hardest part about going faster is being consistent first. The second part is sort of judging the speed entry and where you can go back to power and when, as soon as possible, you can get to wide open throttle. This is turn 1 at Road Atlanta. We are traveling from the top left-hand side to the bottom right-hand side on the map. This red section, the color channel for this heat map is throttle position. And what happens is during the red, the track is actually relatively flat. In the blue, the track drops away at a slight retrograde. Then what happens is right around this second section here where the throttle breathes off a touch is the apex. That is the lowest point, lowest elevation on the circuit. And then the circuit climbs rapidly and generates tremendous vertical acceleration. The car really hunkers down. And if you can get the thing close to the apex and point it in the right direction, you can really commit to throttle pretty well. But here we have a driver that is going 147 miles an hour into this section, and he's going really fast in. I don't know if I can make my mouse any bigger, but
when you pause, it goes off, but it comes as soon as you start moving it. So you'll be okay.
So the issue is we're accelerating fully up to 147 miles an hour. We see the throttle position in green drop. We see the GPS speed drop in a linear way. And then we see a ease off of the brake pressure result in a leveling out of the speed. The deceleration is going away. Now, because he's got his foot off the brake, he's decided to go back to power. And like every good professional driver, if a little is good, more must be better. And right now he goes, more must be better. And then he realizes, yep, the car is not quite pointed in the right direction yet. So I've got to traverse more distance before I do the progression to the completion of wide open throttle. David Free calls it the throttle dance. And that is really, really true. We want steady, stable throttle application. We want all the control inputs to be calm, deliberate, but continuously progressive. Really, really important. We don't want to see the throttle dance. But this is a really, really good picture of what happens in a high horsepower GT car on slicks going really, really fast around Road Atlanta. And it's a lot of fun. One of the things that most drivers, and I would say a majority of the club drivers that I work with, don't do is they don't drive the car to the point where it pushes back. They turn the wheel and the car turns. They maintain the steering angle and the car tracks a radius through the corner the way they want it to do. They apply the throttle only as fast as they think that the car will accept the control input. They never push the pedal early enough or get to wide open throttle soon enough for the car to begin to lose traction, especially talking about big high horsepower rear wheel drive or mid-engine GT cars, which is this car. We have a driver here who has ultimate commitment. Not only is he committing to wide open throttle earlier than even he thinks it's a good idea to, but he's got to do it. But also the car is pushing back. What we're looking at is the right rear wheel speed in pink, and we are looking at the GPS speed in green. It is super important that you look at the different measures so that you can gain insight. If I were to look at GPS speed, I would never know that this guy is really taxing the car, not only braking. So as the road falls away, we're seeing wheel speeds drop in the right rear for a moment going into turn one. We see it at the very end going into turn 5 at Road Atlanta, which is a very tricky multi-elevation change section. No, not downshifts, because this is all automatic. It's a sequential box. It's not an issue where it's electronically controlled, so they can't screw it up. But here we see him pushing the brake pedal so hard at the end of the back straight, the high speed back straight, 160 miles an hour in one of these cars at Road Atlanta, that we see a little bit of rear wheel speed drop there. But most people look only at wheel speeds for braking efficiency. Are you threshold braking? If you don't see the spikes down, you're not threshold braking. So if you have wheel speed data.
Yeah, I'm a huge fan of GPS information like this, but I have always been and always will be having a wheel speed on top of that. There is such good power to GPS information, nice and clean and everything, but you don't see that. You can actually see tire spin and the brake lockup, and it's a great tool to understand how hard the driver is pushing. So well, I gotta tell you, I enjoy it.
I love this driver. I love this driver to death. You know, he's the kind of guy that you wind him up and you send him out. And if you tell him something, you better be damn careful what you tell him. Otherwise, he'll do it and he will sail off into space. I mean, the guy is that committed, which is really, really good. So the other issue here we have at the turn 12, which is a very fast downhill and then level turn to the right onto the pit straight right here. We actually have the right rear wheel touching the inside curbing coming off the ground, and he is buried in the throttle. He is carrying as much throttle in there as he can. The reason why the GPS speed drops is because of the cornering scrub and the compression slowing the car down. But what's happening is here is the right rear tire is coming off the ground and overspeeding, going faster than the actual speed of the car by close to 25 miles an hour. So here we have a really, really good view of the commitment of this driver to push past the point where they're absolutely comfortable. And that is the hardest part of going faster. We'll talk more about that as we go through here. The relationship of the measures is important. You got to validate with GSum. Roger and I had a great time going over with this last night. The heat map, by the way, is GSum. Red is all values over 1.25 G. So the guy is using more than a 1.25 G at all the places that are red on this track map. We can see that here, but we also see areas where even though the speed is going up, we see the GSum periodically going down to close to zero, to the low reading. And the reason for that is because the car is changing direction basically 4 times from here to here. So that is the purpose of these little drops. So the areas of green right here, 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 and here are areas of a change of direction. Again, what I want to know is he utilizing consistently the maximum demonstrated capability of the tire? And he is, which is really, really good. So corner exit optimization metrics. Another way to look at it is steering. I try to get drivers to begin to be so proactive with throttle application that they have to physically open the steering wheel in rear wheel drive cars. So if they have the power, if they have the juice, then what I want to see is I want to see them apply progressively and continuously throttle application from 0 to wide open throttle to the point where the car pushes back and the balance of the car changes because of the throttle application and because of the commitment to the throttle application. And here we have a wonderful, wonderful example of driving into turn 5 at Road Atlanta. You've got to slow quite a bit. Here's the speed. You've got to drop, quite a bit of speed in order to get to the minimum, about a 70 mile an hour corner. And then you need to accelerate. Now, the road is bottoming out here. You're climbing here. It levels out here. It climbs here. It levels out here. And then it climbs steeply, exiting the corner. But at this point, our driver fed in steering. And then as the throttle was coming up, he realized he was getting close to the limit. His butt dyno, his butt gyro, his calibration in his butt said, I better wait before I complete this wide open throttle business. You know what? He was right, because the car said no. And all of a sudden he had to go get out of the steering and go basically back to, if we consider this to be straight ahead or 0 degrees, he almost had to remove all of the lock to turn into this corner because the car stepped out right here. Okay. So this is a great way in looking at this. If you have steering angle input, use it to determine whether or not your driver is in fact driving to the capability or perhaps beyond the capability of the car and has to make a correction. This is fundamental. It's super important. Really, really good stuff. So I'm looking, this is sort of the culmination of string theory, the idea of a string tied from the bottom of the steering wheel to the throttle pedal. As the pedal goes down, the steering has to come out. And that's the key, really important. All right, so we're done basically with talking about getting out of the corner. We're talking now, what we're doing is talking about going into the corner. So the next easiest thing than driving out is cleaning up going in. Now, I'm going to tell you that it is very important to break down braking into several different individual skill executions and control inputs. But number one, what we have to do is we have to accelerate right up to the point where we decide, excuse me, we have to accelerate right up to the point where we decide to brake. Then what we have to do, and this is wonderful because what he's doing is he's accelerating fully, going down the pit straight, and he is going he's going less than 20 feet between full throttle acceleration and the application of brake. So blue is brake pressure, green is throttle, and he is not left foot braking. I have video inside the car. So he's going 147 miles an hour and he's covering 20 feet between and yes, incredibly impressive because it's very, very good. It's super nice. Then what we do is we see a throttle application right after this sort of tail of the braking, which is really, really nice. This is a great.
What I really like about what you've done here is you've taken, you're talking to just cleaning things up, right? So you're showing the throttle on and the lack of time between, and he used the delta function, by the way, to measure that. That's where he got the 19 feet to the brake application, and then coming off the brakes, how long does it take, and making sure that's good and clean. So your feet are doing that dance where you're getting all the timing right, and it's just a critical thing. And it's just one of those things, if you do it right and you start to do it, all of the rest of this comes along well.
That's right. So once we're done talking about that, let's talk about consistency. How do we arrive at the entry of the corner at the same speed, lap after lap after lap, so that we can establish a baseline and incrementally improve on that? Because that's the hardest part of going faster is to roll a mile an hour or 2 kilometers an hour more into the corner. What I'm asking people to do is I'm asking people to break the brake application of slowing the car into 3 steps. Basically, you have the initial application. Now, we looked at that a little bit in the last slide, which should occur as soon as possible after the cessation of maximum throttle. So we have initial application, which is really nothing but the point at which brake pressure starts. The second, we have brake aggression. Brake aggression is something that I first heard from George Seegers at a seminar that he led at PRI in 2007 or 8. And his brake aggression was actually a mathematical channel, manipulation of a raw measure that allowed you to assign an objective value to how aggressive, how much and how fast a racing driver applied the brakes and decelerated the car. So brake aggression is very important. The goal is to achieve as much brake aggression as the platform will stand. So the goal is you want to really test the limits. If you just ride around and do the same thing over and over again, you're not going to get better. So you've got to be consistent enough to be able to do that and really make it work. Finally, the third step in brake application, which is the 3 steps of the 5-step braking process and analysis, is your deceleration consistent? Is it sustained? Is it high and level for an extended period of time? Here, we have a situation where we've got maximum peak Gs, and then he let off the brake pressure and actually may have prematurely let off the brakes just a little bit and had to actually push it a little bit harder at the very end to get the nose down. So this is super, super important. Then the next step would be the brake metric, overlap it with speed so that you can determine, are you progressively and continuously decelerating? Heat maps are particularly effective. The spike in this particular slide is due to the fact that the car has enough aero download onto the tire contact patches that it can stand getting really, really big pressure. Kyle, you got to understand, you asked me how much of this little under braking cost in terms of time. And I would have to say not a whole lot, because the driver is, even though the driver is very good, even though the driver is winning world championships in GT racing, one make racing, he is still not as consistent as he would like to be. That's the key.
And sometimes it's the track. Sometimes it's the car around you. So one little, looking at one lap here, it should tweak your eye, and you should be thinking, okay, well, let's dig in a little bit deeper. Why did this happen?
That's right. That's exactly right. So this is a confirmation of him bleeding off the brakes too quickly. We see a fall off of this GSum, which is really, really good. And then we see it rise back up. And then here, what is basically happening is we got lots and lots of vertical compression, vertical acceleration right here. And that is one of the reasons why the GSum goes up further from a flat level surface braking. So this is a really, really nice slide. But the key is adding another measure to make sure you're utilizing the full capability of the tire. Brake release, the first step. So this is basically the 4-step in a 5-point program. We're bleeding the brake pressure to the end of braking. My colleague and friend Ross Bentley talks about establishing the end of braking as not being the end of the straightaway, but rather deeper into the corner, closer to the apex area is the true end of braking. And that's what we're seeing right here. Dave Arkins talked about how can we overlay lat G, and guess what? The pink right here is lat G. So we see how this blends in, and we see the maximum lateral loading through 10A. This is the back straight at Road Atlanta, basically going from 170 miles an hour to 70 miles an hour right here. It's really, really good. So this is terrific. It's very nice to see how he drags the end of the braking pressure past the initiation of steering, because we're building lateral G's. It's fantastic. It works really well, and it's something that you can use to figure out. So then next, excuse me, just to wrap this up, the second step, or the final step of 5 individual control inputs, points, or areas in a successful braking execution at maximum efficiency, is this one: bleeding the end of the braking into the maximum cornering force. We saw that a little bit in the last slide going into 10A. Here we're looking at the southern end of Road Atlanta, the slowest corner on the track, turn 7. And you see a very quick attack and high brake pressure initially, and then we see it bleeding off as they turn into the slowest corner and head down the back straight. So trail braking into turn 7 at Road Atlanta. It's super, super nice to have this. Just trying to keep this on time. I know, Roger, you are such a great taskmaster. Corner entry speed estimation. That's the next step. How do we figure out what speed to enter the corner? That's a really hard thing to do. Don't scare the car or the brain. Most drivers try to achieve too great a change in too short a time, which is why they crash. So the goal here is to get very consistent at a particular level and then change one thing, which is roll speed a little more. Everyone's natural inclination, especially when they get tired and when they get frustrated, is to push the braking zone. Here we have the red car is pushing the braking zone in turn 3 at Virginia International Raceway. And what they're doing is they're braking late. They are braking not only late, but they're braking so much that they're going 10 miles an hour slower. If somebody is a little bit more proactive and decides to brake a little bit earlier, the green car in this particular instance, plus the green car actually is on the curbing, whereas the red car is not. So we see throttle application on the bottom strip chart. We see brake pressure on the top. This is all from an SD card out of a SmartyCam. This is not any XRK file. So it is useful. It's quick. It's easy. Work with a lot of people in a short period of time. I really need to be able to do it fast. So that's one of the things that we do. Don't scare the car. And more importantly, don't scare your brain. Don't try to push the corner entry so much that you overslow and really compromise your ability to get out of the corner. That's the number one thing. That's the lesson for the day from that slide. Here, focusing on getting off the brake, rolling speed into corner. What people don't realize is every time you turn the wheel, the car slows down. So you can be off the throttle or you can be at null throttle, which is not positive acceleration nor slowing, and still have to give it pretty good throttle as you add more steering input to accommodate the scrub of most sticky GT car, sports racing, or Formula car tires. So in this particular case, don't slow before you have to. And that's the key here. Focus on getting off the brake and rolling a mile an hour or a little bit more into the corner. Back up the braking first, and then smooth does not mean slow. That is really, really important. I think a lot of people equate smooth with slow, and it's not.
It's you're talking about that incremental, finding that spot, a lot of what you're talking about today. And if you look at that slide, go back to that one, and the blue, you can see where the blue driver lifted off the got off the throttle a little bit early, and the braking, and then got after the brakes, kind of moving it back, trying to figure this out probably. And it's the same driver after being coached and after being coached is what we're looking at here.
Right.
And then look, about halfway through he starts to get ready to get on the throttle. He has overslowed it so much that he had to get back to the throttle, then back out and go again. Okay, put that away into the bank and say, okay, well, I need to continue and roll in a little bit to get off the brake a little bit earlier and roll through the middle a little bit quicker. So there was a coaching event that happened here, and this is the difference of that. It's kind of interesting.
Well, that's right. And I got to tell you, I use Time Compare all the time. And the reason I use Time Compare is because it tells me where and how much the change is and how much the improvement or the loss. So I have a net gain right there. And in this particular case, this driver, the green car, picked up, went a little bit deeper, braked a little bit softer, rolled a little more speed into the corner, got on the power sooner, and did all the right things and really gained about 0.7 of a second through one corner of the racetrack. It's
a beautiful thing.
Amazing. It is a beautiful thing. I love it. I do. Most common corner entry error is most people they apply the brakes too soon and they finish applying the brakes too soon. And they feel like they have to go automatically back to power, and beware the double pump. What was it, David Free? The throttle dance. This is really a beautiful example of that. Here we actually have a heat map of throttle position. Sometimes premature release of the brake can hurt more than help. And that is what I'm going to ask you to think about today. So super, super, super important. Let's see. The last, pretty much the last slide we have here, I believe, is,
there you go.
There we go. So this is before and after turn one at Road Atlanta. Turn one at Road Atlanta is tough because you can't see where you're going, and you're going really fast, and you better make the right decisions or you're going to run out of road. And in this particular case, we have, what do we have? Throttle position right here.
Yep.
And so what happens is, just by simply going deeper and braking maybe a little, not quite as hard, and this was a testing lap. So this is where he started. He said, well, I've got to get this thing slowed down. But then unfortunately, he said, whoops, I've slowed down way too soon. Now I got to go back to power for some significant distance here.
Yeah,
that's not good. And that upsets the balance of the car. The car doesn't turn as well under power. And so all of a sudden he's got to let the car slow down, and he's going slow enough here. I guess at the 1500 mark, where he can finish applying throttle just about where he did before. or I'm sorry, where he does later.
Yep.
So later in the afternoon, he said, you know what? I can't bring myself to accelerating hard all the way past where I was and not braking quite. I can't bring myself to braking hard deep into the corner. So I'm going to brake a little more softly, a little bit more sooner as a growing stage. And I'm going to brake softly and arrive at the corner at the right speed. And then I'm going to apply throttle from the start to the end in a particular period of time. So I think this is a really, really good example of how somebody can improve. And in this particular case, it got them about half a second.
Incremental is some of these spots that you've talked about it, and you're going to talk about in the next 2 or 3 slides, bullet items. It's that incremental thing, and there's some places it's safe to make a bigger leap, and other spots you've really got to attack it a little bit slower as a driver coach, helping your driver, or you as a driver coaching yourself. There's times to jump in hard, and there's other times to take your time, and this was one of those.
That's right. So I do see in the chat there's a great deal of discussion about top level F1 data traces. I've been fortunate enough to be able to review quite a bit of that, and it really, really works well, because those guys are at such a high level that they really are, when they go to power, they go to power. When they go to brake, they go to brake. They're consistently close to maximum sustain, longitudinal and lateral acceleration at every corner, unless the topography doesn't allow it. And you're really looking for hundreds, not even tenths. You're looking for hundreds and thousands. What was it? He pipped him by 3 thousandths. It was recent, but anyway. Our whole goal of the presentation today, and we're just wrapping this up, is you need to build a belief system. You need to get to the point where you believe that you're capable, and you believe your driver, you're getting your driver to believe that they are capable of doing more than they think they can. We validate this by using the data, by pointing out areas of exceptional brilliance by that driver and saying, do more of that. It is really important to find, focus, and identify those areas of exceptional performance by yourself and by your driver in the data, backed up with video, so that you can validate the heading of the car, where it's pointed, and where it is positioned laterally on the width of the road. But the first priority in that building of the belief system is always to get out of the corner using continuous progression to wide open throttle. That is the number one. Every driver so George Seegers said to us in 2007 or 2008 at that PRI seminar, he said, I have a really useful math channel. Oops, I did that. I'm sorry. I have a really useful math channel, and that math channel is percentage full throttle over the lap. And if you make a setup change and your driver is very consistent, even if your driver comes back and says, I think it's a little better here, I don't think it's better there. If that thing is a 1/10 better percent full throttle over the course of the lap, analyzing a couple of quick laps, it is huge, big
You're going the right direction.
You're going in the right direction. It's validated. It's not just somebody thinking they know it, So here we have get the car turned downstream so you can fully commit to throttle. That's number one. That's the number one goal in order to be able to use continuous progression to wide open throttle. Accelerate hard enough so you have to open the steering, or you feel and see wheel speed spikes upward. Validate those tractive limits on acceleration with the wheel speeds. And then finally, and this baby should be earlier in the pile here, be against the apex area in the right place every time. I'm asking my drivers to touch a 50-cent piece size spot with the intersection between the tread and the sidewall of a specific tire at every individual corner point, apex area that they are using. Really,
if you're not doing the basics correctly, some of the rest of it becomes harder and harder to do.
Well, I would say that 90% of the problem with club day drivers, DE drivers, track day drivers is they're just horribly inconsistent. They
Yep.
don't do the same thing
Still
lap to lap.
working, still building that skill. Yep.
That's right. So the second priority, harvest the low hanging fruit. Well, you're still going straight. If you're still going straight, you can fix it. If you run into a jam, if the car becomes unstable because of threshold braking, you can fix it. Get out of the brake. Let the platform settle down. But the idea here is harvest the low hanging fruit, get this thing slow down while you're still on a straight. Okay. Accelerate fully until you know you need to slow the car. Accelerate right up to the brake point. Validate with throttle position and brake pressure overlaid on the same strip chart if possible. Braking is the hardest individual skill execution. Why? Because it is influenced by your mind and by your fears and your anxieties and this idea of cartwheeling balls of fire going off the racetrack at the and that's really not funny,
Wow.
is it?
Wow, that was that's a visual.
Bad imagery. But
you made the point was well made.
but it is variable. I mean, everyone adjusts subconsciously their brake pressure to fit the brake zone they think the car is capable of. Few drivers brake to the capability of the car, especially when it's working well. So this is really important. This is why it's worthwhile to work on braking, especially in a straight line where you're trying to get rid of big speed, 60, 80, 100 miles an hour. Get good and consistent at slowing at a high rate first. Establish a brake zone in the brake zone and then move it towards the corner entry. So you're never really changing the length of the brake zone. You're changing where that brake zone is in relation to the entry of the corner. The brake point initiation is not the same as brake aggression, which is how quick you get to the max. And this is why, Matt, I'll tell you, I have difficulty with my colleague Dave saying, well, you just have to brake softer. No, what you can do is you use a later brake point, but then you feed in brake aggression as quickly as you can to peak brake pressure as quickly as it takes not to upset the platform. That's all. Your goal is to compress the braking zone, especially in a straight line braking zone, and then move that braking zone, have it be consistent from lap to lap, and move it progressively and incrementally into the entry of the corner. Brake hard early in the brake zone, and if you feel like you have to let off too much, compress the brake zone and then move it in.
That's an easy way of becoming slightly more uncomfortable, but at a lower risk, right?
That's right.
You slowly just step into it because you're still going straight.
That's right. So coming to the last part, and this is really the discussion that sparked the title of this webinar, is the hardest part of going faster is the area with the highest risk. And we talked about this. Roger and I had a great time talking about this last night because we all know these places. Everybody on this webinar knows whereof I speak. The hardest part of going faster is in the area with the highest risk, and that is the corner entry from the end of braking past the initiation of steering input and managing the transition between the end of longitudinal G slowing to max cornering, because that is what separates the good drivers from the great drivers. There is one quality of professional drivers, sports car drivers, and GT car drivers that I look at, and that is almost all of them slightly overdrive the car into the corner, slightly go in too hot, knowing that their butt can process their gyro, can process a potential problem, and that they can fix it before it turns into a big problem. We've heard F1 drivers say, I must have crashed almost 100 times that lap. Well, you look at the video and it's sublime. It's beautiful. And the point is that they are recognizing before a less experienced, less capable, less talented, less practiced driver might, all of those things, and they are pushing the envelope. They are becoming comfortable being slightly uncomfortable. The first order of business is to practice rolling speed deeper into the brake zone. You really got to get it. You can't slow so much that you're puttering into the corner. You can't do it. There's got to be energy in the car that you can use to begin initiating rotation or a differential in the slip angle of the front axle versus the rear axle. The car has to do some of the turning work. How do you do this? You lessen the brake pressure earlier to arrive deeper in the brake zone with more speed and energy. So extend the taper off of brake pressure, and then extend the end of the braking zone towards the apex area. And I say apex area because very rarely is it one single point. It's an area where people are most close to the inside. End of braking is around the corner on some of the slowest, longest corners. You have to realize that. Dion von Moltke, Racers 360, was one of the first people that I heard verbalize this the correct way, which is we want to finish the braking at the point where we want to be going the very slowest, which is at a point where we can go back to power and continuously and progressively apply throttle to wide open. Practice incrementally rolling 1 more mile an hour, 2 more kilometers an hour into the corner until the car pushes back. You must, in order to do this, you must push hard enough so that the car pushes back. If the car does
not hitting back, but pushing back.
That's right. That's right. If the car's not pushing back, you're leaving something on the table. This is not the street. This is the track, and that is the purpose of this. And thank you so much. I really appreciate it, Roger. I thank everybody for putting up with my unending enthusiasm. Oops.
I got it.
Okay. All right.
I got it.
And I thank everybody for attending, and I really appreciate it. I mean, it's really a lot of fun.
Absolutely. The what I found from this as we kind of close it up is the becoming comfortable with being slightly uncomfortable is a statement, and that's fine, and there's no doubt that that's true. But what Peter did is he broke it down and gave you some steps, especially on the braking side, that area where it gets a little dangerous to be uncomfortable, and broke it down into these areas where you can actually work on one area at a time, at least mentally. The really good ones, and as you get a little bit better and you're doing this a lot, it ends up being one motion, but you're really doing these 3 or 4 to 5 different things. And I thought that was very helpful in ways of doing that. The one I come away with as big as anything is cartwheeling ball of fire. If you do it wrong, I had to write that down. So that's a pretty good statement. I appreciate everybody coming. Let's kind of close it down a little bit. This video, as soon as we get done with it, I go to work as fast as I can and get it up on YouTube as quickly as I can. I know here in the States, we're taping this in the middle of the day, and a lot of folks watch it as soon as it shows up on YouTube because they can't watch it live. So get it up there. This will be number 180 of videos that we have up there, all of the webinars, plus a bunch of other videos that you might want to go and take a look at. So go check it out. Covered a lot of stuff. Peter went through some stuff really quickly and with great enthusiasm, as always. That's what we love about it. But boy, there's sometimes when you're thinking about what he just said, maybe you missed the next statement. Go back and rewatch it a little bit. I think you'll find that there's just tons of good information that's hidden in all of these. We're out at the tracks a lot. I know Robbie was at a track this week, and I think most of our folks were. This is the busy time, right? And so look for us out at the track. You know, we're a training and support company that happens to sell electronics, is the way we like to look at it. We're out here for you. Let us know what we can do to help you. Love to give you a hand and to get more important information, more speed out of this hardware that you've invested in. So give us a holler and let us give you a hand. So next week, a week from today, we're going to come back with a fellow that's in our, joining us live today. David Free is going to join us next week. I think this will be maybe his 3rd or 4th webinar. Everybody always enjoys chatting with David. He's a good old school racer, has lots of great information and background and experience, and yet he likes to use a lot of the data to do some things. And what David is going to talk about is you show up at a track. I'm a new driver to this track. It's a tough track. Yeah. How do I use data to some tips and tricks on how to use data to get up to speed fast when you show up at a new track? I think it's going to be fascinating. It's going to be just another new cool way of looking at data and applying the stuff that we love and getting it to add value for us. So looking forward to having David with us next week. Looking forward to it. The contact information for myself and Peter, Peter's information there down below, email and his websites and such, mine there on the left. I feel like after every one of these, I think this was Peter's 8th webinar. I feel like after every one of these, I should not get paid for the last, the day of working on this particular webinar. I got to sit back. I was sipping on my water and just watching. So I feel like I've not put everything into as much as I should have. But anyway, Peter's great. I appreciate you coming, Peter, as usual. Anything you'd like to kind of add as we kind of close this one down?
No, I'm just looking forward to hearing what David has to say next week, because he's a great resource. He's very practiced. He's worked with a wide variety of cars, and I always learn something when I listen to him. So I think that my hat's off to AIM Sports for building this series and promoting this series and continuing with it, because it really does help a lot of people.
I agree, and we're going to continue to do them, and look, and we'll have you coming back. And what we chatted a little bit last night, and we'll chat again in the next couple of days, is some of the points you made in here are deserving of a little bit more focus. And so I think we'll bring Peter back and maybe talk about a couple of these things, depending on feedback. Go to YouTube, drop me a Peter notes. What was some stuff that you might want to dig into even deeper, and let's chat about it. Again, appreciate it, everybody. Thanks for coming, and hope everybody had as good a time as I did. Looking forward to seeing you all next Tuesday with David. It's going to be a great time. Everybody have a great rest of your week and a weekend at the track. Talk to you all soon, and see you later.
Buonasera.